Hi everyone, my name is Irina Chuvashova. I'm a postdoctoral fellow at Geophysical Lab at Carnegie Institute for Science. I'm working on direct measurements of thermal conductivity of ferropericlase and bridgmanite at high pressures and temperatures. We all know that the core-mantle boundary is by far the most important thermal boundary layer inside the Earth. And one of the reasons for that is that the heat flow through core-mantle boundary largely controls the thermal evolution and structure of the Earth's interior. Since the heat across the boundary is only transported by conduction, understanding terrestrial heat transport requires knowledge of the thermal conductivity of the mantle-forming minerals as a function of pressure, temperature, and chemical composition. The available experimental data are limited and inconclusive, causing the geodynamical studies rely on theoretical calculations and large discrepancies. Iron and aluminum-bearing bridgmanite and iron-bearing ferropericlase are the most abundant minerals in the Earth's lower mantle. Therefore, their thermal conductivity is of great importance to assess the thermal conductivity of the lower mantle. We're here in the laser lab, where we have developed a laser system for direct measurements of thermal conductivity of ferropericlase and bridgmanite at high pressures and temperatures in diamond anvil cell. So we place the sample here, and we use continuous infrared laser for background heating of the sample from both sides. And we use the pulsed infrared laser to heat the sample on one side in microsecond pulses. Fast measurements of thermal emission allows us to resolve the heating response through the sample and understand the tendency of materials behavior within the mantle and core. Recent addition of the Pockels cell allow us to shape the pulse to a near square, nearly 1 microsecond long time dependence, which simplifies the complex calculations. Once again, my name is Irina Chuvashova. I'm a postdoctoral fellow at Geophysical Lab, Carnegie Science. If you're interested in learning more about direct measurements of thermal conductivity of bridgmanite and ferropericlase at high pressures and temperatures, please come to my talk on Tuesday, December the 10th.